For example 8, let f of x equal this rational function, x squared plus x minus 2 all over x cubed plus 6. We want to find the first derivative. When I look at it, of course, I can see that it's a quotient of two functions, so I'm going to have to use the quotient rule on this thing. And we saw from the quotient rule just a minute ago that, it can be challenging to actually apply. But are you up for the challenge? Because I think you are. I think you are. All right, so here we go. So f prime of x will be equal to the derivative of the top, which is 2x plus 1, times the bottom, which is just x cubed plus 6, minus, and then the top stays the same. So top times the derivative of the bottom, x squared plus x minus 2. And the bottom's derivative is a 3x squared. All of this over the denominator squared. So 3 plus 6 and square it. Should we expand out that denominator? No. Instead, though, we do need to clean up the numerator. So we'll have to do some FOILing here. So 2x times x cubed would be 2x to the 4th plus 12x, and then plus x cubed, and then plus 6. And then here we'll have to distribute both a negative sign and a 3x squared. So that would be a negative 3x to the 4th and a negative 3x cubed, and then a positive 6x squared. All of this over stuff squared. All right, and then maybe combine some like terms or something. Who knows? Maybe something's going to cancel. It won't. But, you never know. You never know. So let's see. Combining some like terms. I've got 2 of them minus 3 of them gives me negative x to the 4th. Let's see cubes. We've got 1 minus 3, negative 2. And squareds, we got 6, just 6, so plus 6x squared. And then the linear term, we got just a 12x, okay. And then constant terms, plus 6. Well, that's it. I mean, you could go through the effort of trying to factor that if you wanted to, but I'm not gonna. I'm just gonna leave it like that. And I have the first derivative. Okay, so what we like to do, of course, is graph them together. Do you have to do this step? No, but I'm trying to model like some, or suggest some relationships, reinforce some relationships between the graph, as we see it right here, and the graph of the derivative there, which you can see that the graph of the derivative and the graph of the original one still has a vertical asymptote right here at well, I guess it would be the cube root of negative 6, right? Yeah, because the denominator on both of them stay the same. Okay, we can see that because the green graph goes up to infinity on either side, you got some rapid growth, right? So you're approaching a vertical tangent line, and that's definitely true. You can see that it crosses the x-axis right here, which means that even though it's hard to see, there should be a little hump there, a little relative maximum.